Today we're going to be solving equations that have variables on both sides. So when we've talked about isolating a variable, that means to get the variable by itself on one side. Now how do we do that if I have variables on both sides of the equation? I'm going to show you. Okay, so same thing, we're always going to start by drawing our fraction bar. And your job, your first step is always going to be trying to get these variables to one side of the equation. It does not matter. I can decide to get this 5x to this side of the equation, or I can decide to get 2x to this side of the equation. It doesn't matter. However, you want to do what's easiest for you, and you can't just plop it on one side. You have to remember to do the opposite operation every single time, okay? So keep that opposite in mind every time. Okay, so here are my steps. I'm going to hold off on example 1 because we're going to do that tomorrow. But we're going to start by eliminating the variable from one side of the equation using what I just said, opposite operations. So if it's a positive 2x, you're going to subtract. And if it's a negative 2x, you're going to add. So it's always going to be plus or minus. And then everything else after you get those variables to one side is going to be exactly the same as what we've been doing, because we always have to remember to keep our equations balanced. All right, so really our first step is the only thing that's going to be different for us today. So in this problem, I see two variables, okay? I've got a negative 2m and a 4m. My job is to get those to one side of the equation. So just because it's my choice here, I'm going to actually decide to get this negative 2m to this side of the equation. So if I want to move a negative 2m, I'm going to do the exact opposite of that whole thing. So the opposite of a negative 2m is a positive 2m. And I'm going to do that on both sides of the equations just to the variable. So these go away. I'm left with 13 equals 6m plus 1. Now I have m on one side of the equation, which is great, and now everything is just like normal, like I was doing the other day. So to get m alone, I'm going to subtract 1 on both sides. So I'm going to have 6m equals 12. One final step, I'm going to divide by 6 on both sides, so m is equal to 2. Okay, I'm going to try one more with you and then have you try the others. So over here, I'm going to draw my fraction bar, and you'll notice that I have x's on both sides of the equation. If there's no coefficient, no number in front, I'm going to give it a 1. So I have 1x and 3x. Now remember up here when I said it doesn't matter which side you get it to? Now in this type of equation, you'll see why. It's going to save you time if you make the right decision about where to put the variable. You're not going to be wrong, but there's one little thing you can do to think about that will save you some time. Now I could move 3x to this side, but if I do that, there's nothing left on this side, and that just creates more work for me. So I'm actually not going to do that. You could, wouldn't be wrong, but it's going to be more work. So I'm going to choose to get this 1x to this side. So to do that, I'm going to do the opposite. I'm going to subtract 1x on both sides. I'm left with 10 equals 2x. Now I really only have one last step, is to get rid of that 2. So x is equal to 5. Okay? I'm going to have you go ahead and try these last two and check your work when you're done.